everyone! Today we're talking about the history of the periodic table development, and amazingly enough, the periodic table did not start with a table. It started with a list from Antoine Lavoisier. This is the first known gathering of elements that to date. And so in 1790s, Antoine Lavoisier, who was a French revolutionary and a French scientist, put together all the elements that were known to man at that time, and there were, get this, 23 elements. And they were elements such as gold, silver, oxygen, hydrogen, bismuth, all of these lovely things that had been known basically since prehistoric time. So this was not necessarily new information. It was just information that he gathered all into one place and started organizing it. If you look over on the screen here, you can see his initial list, his original list in French of the periodic elements. As we move forward in time, this is 1790s. The 1800s is really important in science and social studies for a lot of reasons. Big things were happening. The main big things that was happening was the Industrial Revolution. And that was really important for many reasons. First, it's important to note that basically everything that can make money, people research. So they began to understand things like petrochemicals and soaps and dyes, and the fact that, to be honest, people didn't want to go out and make their own soaps and dyes and petrochemicals. They wanted easily and ready to go from the store, as much as they did in the 1800s, and so they started new chemistry industries in this revolutionary era where you could mass produce something, or beginning of mass producing stuff, and you could sell it on a catalog or in the general store, and you really didn't have to go and make it yourself. But the reason that chemistry is important is that it's important to understand how to balance soap with lye so that it didn't burn people, it cleaned without burning people. Dyes were important because chemistry helps you get all those different colors. And petrochemicals, these are your oils, because they had the oil rush in the 1800s. Moving forward, there's a lot of also scientific advances. The advantage of electricity is that it allowed the energy required to break down compounds into their basic elements, because you just don't walk around the earth and go, oh look, here's a chunk of sodium, and then you're able to look at the chunk of sodium. Or you can't be like, oh look, here is some random chlorine floating around, and you're able to look at the chlorine. It comes in compound forms because elements want to be stable. So sodium chloride, sodium fluoride, potassium iodide, water, all of these things come together. So scientists were able to start breaking things down into their original elements and use a spectrometer to identify them. So really big is they were able to do that, and they were able to realize that it went from 23 to 70 elements by the end of the 1870s because of these advances. We're still using at this point in time atomic masses to standardize, because we could more easily, or they could more easily identify the proton. Electrons were not as known yet, and even protons weren't super well known, but they were able to determine that everything had a unique mass, which we do know is true. So that's very cool. And then they started to try to organize it from the list into a table. And John Newland noted that every 8 elements, the properties repeated. So if you look across the periodic table, not including the transition metals, you'll notice that there are 8 rows of representative elements as columns 1, 2, 13, 14, 15, 16, 17, and 18. These are called the representative elements because it basically represents the expanse of the periodic table. And if you also look at them, every 8 elements, also 8 columns, the properties repeat. Currently, he still based it on atomic mass, but he called it a period. He called it the law of octaves, because if you're playing music, 8 keys is an octave, and they repeat every 8 keys. Unfortunately for John Newland, this was still the time where scientists were considered to be very, fancy. They didn't want the everyday man to be in science, and the other scientists kind of laughed at him because they thought the law of octaves was unscientific because it was based on music. Cheapy people would understand it. So despite the fact that he was right, and more right than most people at this time had been, he still didn't get the credit he deserved till much, much later because people thought it was unscientific. Then we have the 3 M's, Mayer, Mendeleev, and Moseley. And this truly was the 3 M's. Moseley came later. So let's talk about Mayer and Mendeleev. Mendeleev and Mayer both understood the organization and correlation between atomic masses and elemental properties. Remember, at this point in time, we are still using atomic mass, not atomic number, to organize the periodic table. Mendeleev, he organized the first periodic table that showed it as it was. He left blank spaces where undiscovered elements were going to go, and he spent his life knowing the periodic table. He knew it so well that he was able to predict properties of elements that hadn't been discovered yet, simply based on the observed traits of the other elements. He was so sure about this that when new elements were discovered and they didn't match his data, he, 1, argued that the person who discovered it was wrong, and 2, saying he should have gotten credit for the discovery because he thought of it first in his mind. And the crazier thing was, he was right. His data was supported, and the person who found it, their data was flawed. So Mendeleev is considered the father of the periodic table, and his table was more right at this time than everything else, but it still wasn't fully correct, simply because he was still using atomic mass and not atomic number. And if you're wondering what happened to Mayer and Mendeleev, they both published around the same time somewhat similar periodic tables. Mendeleev published first, and Mayer didn't get the credit. And then finally, there's Moseley. He reorganized the periodic table of Mendeleev's, which included newly found elements, and he discovered that each element contains a unique number of protons in their nuclei. And ta-da! We now have atomic number and not atomic mass. And he rewrote the law of octaves to call it the periodic law, which is the periodic repetition of chemical and physical properties that are arranged by increasing periodic number. And that, my friends, is the history of the periodic table's development.